Right, so my name is Jacques de Vos, a Dutch name, surname, but my ancestors moved to South Africa 300 years ago. So yeah, that's where I live, and that's where I do most of my work. I'm a software engineering coach. What that means is we help software companies with software at the heart of it, with everything related to their software engineering, from the agile coaching side to DevOps to how we write unit tests. So we like to look at the whole picture and help them optimize. And we also build a few of our own products. So during this, we're always looking for what is the best way, because we're supposed to be the experts. We're supposed to be showing others what the best way is. But there's a conflict in that. I've realized that if you have this view that there's a best practice, you might end up in pretty dear circumstances. So this picture, it was shown to me by friends of mine that hiked to the Everest base camp. And this in Nepal is the airstrip, the closest airstrip to the base camp. You have to land here, obviously very dangerous short airstrip. And what this reminded me of is this problem I was seeing with best practice. What a lot of teams try and do, and I've done it myself numerous times, is you build a Boeing and you try and take off with the Boeing from this airstrip. So what will happen? You'll see nice fireworks if you try and take off with a Boeing from this airstrip. And the opposite is also true. If you try and load this Cessna airplane with 100 people, you'll also crash. So if you're working on mature enterprise products in the way you would with a startup, you'll also crash. So this is the kind of growth I've gone through and the kind of learning. So. And this might be intuitive to you. You might have seen this pattern before. It's not all software products are the same, or not all phases of software life cycles are the same. The amount of unit tests, like you pointed at, the amount of upfront analysis, these things differ. And there's no hard rules that help us decide here. And I think a lot of us in the industry have come to recognize this. However, most of the debates, like you've actually mentioned earlier on, is still, no, we need test coverage of X, or, this is the right way and that's the wrong way. So most debates are still done in that way, unfortunately, because our industry don't yet have ways to think about it. We don't have the classic book that describes when to do what. Maybe that book will never exist. So luckily in the last, I say 2 or 3 years, there were some prominent thinkers that applied their minds to this. And I actually want to today introduce you to some of these concepts. There's no books here but about these things, but there's blogs and there's videos about them. So I just want to get a feeling, who's heard of Kent Beck's 3X model? Have any of you heard about it? No? And Simon Wadley's value chain maps. Have anyone heard about it? Spine model and deal track development, Jeff Patton. Great. That's the purpose of this talk, is to share what I read about these speakers and how it influenced me, and also how I, from reading all of this material and thinking about it, how I came to recognize these 3 factors. So these 3 factors, in my mind, is the things you should be looking at before you decide what your good practices are, what the right practices are for your environment. So the first practice is product maturity. Where is your business? What's your business model? Where is your product in its life cycle? And then the customer needs. Obviously, that should actually come first. And then the final thing is execution risk. So I'll unpack these while I introduce these other models. Let's start with product maturity. What do I mean with product maturity? It's useful to think in terms of evolution of a product, like the evolution of a technology. Technology might start with an idea, genesis, and then somebody might custom build once off for one client something in that technology, and then it might become a product in a box, and then become a commodity, just available everywhere. Think about computing. The first programmable computer, the idea, can anyone guess where that? About 1850. Charles Babbage and Count Ada Lovelace, they designed conceptually this beautiful programmable computer. They never built it. The first custom built computers were in the late 30s, 40s. There's a German guy, Konrad Zuse, who built the Z3 computer in 1940. Custom built. At that stage, all the computers were custom built, unique, individual specimens. And then the IBMs came along, and you started buying computers as products, programmable computers, literally in a big box, maybe the size of a big room. And then they became smaller. Think of the Dell servers, etc. That's in a product phase. And now we're hitting a point where computing has become a commodity. It's available everywhere. You just pay for memory processing, disk space, on Azure, AWS. It's starting to become a commodity. You just pick one. So that's what I mean by evolution. So you can actually think about any product as following this kind of, let me say any successful product as following this kind of life cycle. You might have seen this curve before, the sigmoid curve. It's called the diffusion of innovation. That's also a nice way to visualize this evolution over time against the adoption. So very old idea. Your early adopters try out things, and then when there's something really useful, there's an exponential growth curve, which flattens out when the product matures, when everyone's adopting it. And in these various phases, there are actually different business models. You get your startups here in the front, and then you have the big growth spurts, and then stable companies. And nothing wrong with any of these business models. Actually, these last ones are the ones that usually pay our salaries. So even though the startups sound more sexy, they don't pay, they really pay the salaries. So Ken Beck, one of my heroes, the author behind Extreme Programming, a test-driven development. I think Extreme Programming is the most phenomenal software engineering book ever written. He started working at Facebook with his mindset of, extreme programming is obviously the right way to do things. And he saw things done in very different ways. On the one side, these cowboys, and on the other side, these long planning cycles. And he realized, oh shit, I have to, what is happening here? Why is this working? They're not following my model. So he had to reinterpret the way he looked at software engineering. And what he came to is this curve, this diffusion of innovation curve. And he identified 3 phases. And in each of these phases, you would work in a different way. The good practices would be different in those. Even the principles, the practices, everything would be different. Like you mentioned earlier, you're working in a startup, and some of these enterprise developers are critiquing you in how you're building a startup. Well, he said, no, that can't be the case. Because if you think about what you're trying to do, when you're in a first phase, you are exploring. Calls it the explore phase. This is like where pioneers live. That's where, think about a pioneer looking for gold. They just scout everywhere, hoping to find something. Dig a hole here, dig a hole there. It's also similar to buying lottery tickets. you buy many hoping to one of them will make it big. That's almost the extreme case of exploring. So you do things cheaply, you do lots of experiments because nobody knows what will hit that exponential growth. Nobody really can predict what a market really wants. It's one of the facts that you have to face when you're an entrepreneur. And then, okay, then you, at the other end of the spectrum, you have mature businesses. Think of it as town planners. If I have a city with 10 million people, I can't just go and experiment with their housing. I need to make sure that we can handle the scale. We need to make sure that the quality is right, because people will die if we don't. So there's a very different mindset there. Think of it as where there's a lottery ticket on the left, on the right it's like opening a bank account and getting a very small interest on your small returns, safe bets, very calculated. So these phases differ. So, and the way you go about things, the way you think about things, very different. What might be, so just example, in explore phase, why write unit test? Why care about reuse? You are going to throw away, if you're really exploring, you're probably going to throw away most of what you're doing. It's about speed here. Unless your hacks are slowing you down, that's not the right way to go about it. This comes from Kent's, Beck's, the TDD author's mouth. Don't test when you're really exploring. And then something happens, exponential growth. Well, it's hard to plan there because things happen to you. Suddenly things don't scale or new features are needed. That's also a very reactive phase, but a lot more disciplined and a lot more need a proper engineering hat. You need to start hardening things. And then you have an extract phase. Well, there it's about well-planned, stable bets. It's return on investment calculations, and that kind of thinking is the proper thing to do there. Okay, so I hope you get the picture here, but let me just tell you a few of my own experiences recently that that would color it in a bit more. So think about explore, think about that runway, and having a short runway. The one business came to us, well, they're not really a business, startup came to us, and they outsourced the building of 3 platforms, iOS, Android, and web development, to build this Uber for home chef solution, so that you can buy food from your chefs in your neighborhood, home chefs. Wonderful idea. Everyone loved it. Chefs signed up, and then nothing. They were on TV, they were on radio, the market did nothing. And they said, come, help us, what's wrong with this? Well, we couldn't really help them because they were only at the starting point. They only did their first iteration of Explore. What they needed was something lightweight that they can continue trying until they find something that people really need. So they really burned through their runway before even exploring much of the market. So that's a bad case. And the lean startup methodology clearly describes how to think in this stage, at least from a business model perspective. But your engineering practices should follow. And we did that in a recent product we're working on currently. It's a solution similar to Uber for security. So there's you have a lot of private security vehicles in South Africa. Crime is a problem, and you want kind of like an Uber driver with if somebody logs a panic, they need to see the location and get routed there. Good idea. Actually, our first client is Uber for calling security devices exactly like Uber. So we're building Uber for Uber. Very cool stuff. And a few other people also tried this, but we said, hey, hang on. We know it sounds like a good idea, but we don't really know what the market wants. So we started kind of just almost hacking together initial prototype, started showing it to people, started running it in the alpha, and then we started learning things about the business. We realized we were focused on the wrong the customers. We should be focusing on the supplier network and their needs, and we started building the system to serve their needs. So we learned a lot from this. And then a few months back, Uber said, we want this rolled out. And we tested it on 4 devices, and it didn't scale. It was supposed to be a real-time system, but it didn't perform. So did we do something wrong? 5-year-old, 10-year-old me would have said, yes, where's your scalability initially? We didn't do anything wrong. This was the time to say, now we need to harden. And we started putting down tests. We started writing load tests, functional tests. We really started hardening our system, optimizing parts that were slow so that we can scale out to a large amount of cars, and also just the quality in general we picked up. And that's what this expand phase is about. We hit the market and we responded to the problems one after the other. And it's too early to tell yet, but we can see the growth is happening and we're reacting to it so far. Then the next phase is extract. What if we've made it? What if we have the golden goose, it's making money, paying everyone's salaries? What do we do there? Well, at that stage, people normally rely on your solution. You can't rock the boat. There's normally also a large amount of users. So you need that more conservative mindset. This is where the town planner comes in. So a quick story of a case where a team I worked with, very entrepreneurial minded people, love to innovate, but they host more than 2 million emails in South Africa. That's the biggest mail provider there. And they innovated and they innovated, and then they deployed something into production, and a couple of 100,000 people's emails got corrupted. Okay, that's not something you mess with. You don't mess with people's email. You can probably go to jail for that, or you should. So this team realized that they should work in a different way. There's something missing. And we did some training and we started building a test pack. One of the best test suites that I've seen, unit tests, integration tests, the work. And once they got to that point, they could reliably start adding functionality again in a very safe way. They just took on this policy of 0 defects, nothing. So no chances. You write the test first. If you find a bug, you write the test. It's that kind of 0 tolerance mindset. And that's often a very appropriate mindset to have in this extract phase. If we have our pioneering hats on and we're hacking and we're innovating and we're doing hack days on our production extract code, it might get our business into serious trouble. So extract hat. So these 3 phases are different roles that you play as a software engineer. You need to understand what the business is trying to achieve in that stage. And then you'll realize there's different level of practices. There's different things you are optimizing for. So that's product maturity, the first aspect. Does that make sense? Does that ring a bell? Does that fit any of your experience?
Yeah, my experience, a lot of the sessions are always, stuff you find on the internet are always targeted towards the last phase, towards the extract phase.
A lot of it is targeted towards the extract phase, because that's seen as proper engineering, but it just optimizes for something else. You'll see Eric Ries from Lean Startup, he's actually explicitly says Don't worry about some of those things. You might still worry about things like user experience because you want to test the experience of a user. But you're right. It's absolutely the last phase dominates our thinking. So next aspect is customer needs. What do the customers actually need from us as engineers? That should actually be the first one and the top one. And there's two models here that I find useful in helping me focus on that. The first one is called the spine model. You might recognize the middle three from extreme programming, practice, principles, values. Spine model adds needs and tools. So what this gives you is, it's just a conceptual model to say, if you're having a debate about tools, .NET or Java, or Node versus Ruby, or whatever debate you're having, usually these debates are silly and useless. I don't know if you've had that experience. All the time. So this model says, hey, before you have that, if you start going into that debate, why don't you ask yourself, are we trying to implement the same practices? Are we trying to do the same thing? Are we trying to work in the same way? Well, if we're aligned on that, our chances are better at choosing the same tool. If we're not aligned on that, are we aligned on principles? What kind of principles do we have in our development team? And then what are the values? What are the things we value as a company? And then ultimately, what are the user needs? Let me just give you an example. So should I use Gherkin BDD test specifications? I don't know who's heard of that. It's a tool for doing behavior-driven development. Well, I've heard a lot of debates about this, but maybe let's take it one step up. Let's ask the question, are we trying to do specification by example? That's a practice. That's a way of doing your development, taking your requirements from examples in conversations and writing those into tests. Well, if you aren't, then maybe it's the wrong tool. If you are, then probably on the right track. Well, specification by example would only make sense if we see design as a joint collaborative activity between our product owners and our engineers and our UI designers. Do we see, should requirements be a collaborative activity, or should it be thrown over the wall in a big spec? Well, if we don't believe that, then Gherkin and specification by example probably won't make sense. But let's take it one up. Do we, in our company, in our company culture, value collaborative problem solving? Do we value owning things as a team, as a group? Or are we very siloed in our functions? So that's quite a high level value in a company. You can see how that ultimately influences your tools. And then finally, the user need is, are we trying to build systems that are easy to use, or are we trying to build simple things? And that might be a user need, which ultimately guides this whole spine. So this is a kind of a generic conceptual tool, just to help you lift the conversations. We often end up with really annoying conversations down here that don't end up in any agreement. So this is just, let's lift it up. Let's get agreement there first. I found this very useful, and I recommend you just go read a bit about it. It's simple to use, but it's quite it's not practical. It's very generic. It's not a tool or a technique that we can just start applying to our system now. So the next one, and I know I'm introducing a lot of stuff for the last session of the day, but the next one I think is quite useful. It's called the Value Chain Map by Simon Wadley. So what that is you start with your user need, the job to be done, if you will, the main thing a user needs from you. In this case, one of my clients had an enterprise payroll solution. The problem is you need to pay 10,000 people in an environment where there's lots of rules and regulations. Okay, well, let's start breaking this down from the user need down into features, the payroll service and the payroll support, because it's difficult. And you can start breaking that down more and more and more until you maybe get to an infrastructure level. Very useful exercise, because what this does is everyone in the company and every component we have, or system or microservice or whatever subsystems you have, gets aligned to what are the needs we're fulfilling at the end of the day. So everyone's much more focused on the user and what they need. So it tells you why you are there. Okay, so that's a chain of customer needs, almost like a mind map. But Simon Wadley goes further. He says, let's take that, remember that evolution of a technology or evolution of a product idea. He says, let's plot that on our horizontal axis and take that value chain of customer needs and plot it or map it against that to start seeing our solution in terms of the evolution of components. So in the case of this customer, there was a support part. Part of it was self-help and a part of it was logging tickets. And we realized that the team was spending a lot of time building a custom ticketing solution. And they were feeling, enjoying themselves, new technology, having fun. But there wasn't any real value for the customer, because in actual fact, ticketing solutions like Jira are almost a commodity nowadays. A dime a dozen, just go buy, switch one on online, pay a monthly fee. So in this case, we realized, hey, there's actually open source solutions. We just have to customize it a bit. This is where the value was. So the team realized that they need to focus their innovation on the more domain-specific, say, configurable tax rules in this case. So this map kind of showed us where we are innovating too much and where we're over-engineering and where we should be moving towards. So this is a value chain map, and I think it's very useful thinking tool. It helps you to create situational awareness. Where are we? The 3X models tells you how to behave in the different phases. I know we just touched it lightly. Ken Beck writes a lot more on that. This tells you where are we? What should we be doing? Developers love innovating. So we love reinventing the wheel, thinking we're always custom building and always doing new things. But in reality, the novel part of your application is often much smaller than you think. So that's the next step. We need to start with the customer needs and the why. Then, firstly, before I go on, does that make any sense? I know it's a very brief introduction. Yes, just go and have a look at there's a couple of videos by Simon Wadley. I think he was a CIO at, what's the company behind Ubuntu? Canonical. He was a CIO or CEO at Canonical. So a lot of these ideas came from his work there. So the last aspect is not related to customer needs and not related to your product maturity. It's just your specific product and where it's now, and the project you're trying, and the features you're trying to complete. What are the risks there? So, and those risks I like to see. There's two dimensions to it. Are we building the right thing, and are we building the thing right? So those things are always worth considering. And we first place where we get things wrong is, are we building the right thing? It's no use building a great quality system if you're building something that nobody needs. So are we building the right thing? And in this design thinking and iterative ways of figuring out what the market needs, those are the kind of tools you can use. This is a model called dual track development by Patton. You might have heard of him, author of user story mapping. But his little process model here is there's a kind of a parallel track, not even completely a different team of analysts and designers just validating ideas before it gets into the main development sprint. And then the key thing is they throw away stuff before it gets to the development team. So if people in teams that don't throw away functionality before it gets to the teams, that's a good sign that they're not really doing design thinking. They're not really validating. So this kind of model really helps. Don't really have time to go into it.
This is similar to just doing development spikes, then, isn't it, as part of the sprint?
It is similar to a spike. The only difference is I think there's two differences. The one is it might not actually be actual code. It might be some design prototype, investigations, design prototype. And the other thing is there's often user validation involved, checking it with a user. So there's a book confusingly called Sprint by Google Ventures. It's got nothing to do with Scrum. It's actually has to do with how to go about validating the core assumptions of what you're trying to build. But it comes down to making your assumptions clear, and then something like a spike, testing whether that's valid, preferably with real users. So that's the kind of method. Exactly the idea behind a spike. You're absolutely right. The idea is throw away. Throw away. So very similar. So building the right thing. Then the other class of risk is, are we building the thing right? And this is often not given the priority it should be. And a quick, easy tool I use to help with this is, let's rank our quality of service attributes. Some people call it non-functional requirements. I don't really like that term. So these are defined by ISO. These have been known for years. But let's have a backlog of these. Let's start understanding what does it mean to build our system at the quality required of it. And when you do this, you often see very interesting things. What you often realize is functionality might be way down there for the users. They don't care. They just use one or two things, but they might want it to be very reliable. Like my cell phone company. When I want to do a top-up, I want to do a top-up. I don't care about the animations and the new little bonus features they've built. I just want it to work. And I get furious because it doesn't. Because the sad part is a lot of development teams are run like feature factories. Features, 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 features. Just pushed out all the time without really thinking about what is important and what is our quality of service attributes. So for me, is building the right thing, and building the right thing. I would say a lot of the traditional material on software engineering speaks to this. How do we build things that are maintainable? How do we build things that are secure? How do we build things that are easy to scale? That kind of thing. So this is where all of these factors play a part. So the risk of your particular project. Yeah. Does that make any sense? I think these models have been, this has been understood for a while. Who remembers the Barry Boehm's spiral model? I think it was created in the 70s, a model for iterative software development. I don't think people really paid enough attention to it, because what that model did was say, we have iterations of delivery, and we put down the risks, the biggest risks. And at each iteration, we evaluate the way we work based on those risks. And I think maybe we should bring back a bit of that thinking. I think part of why it almost disappeared is because, like everything else, when it hits the late adopters, it gets abused and the meaning changes, like we see with all the hypes.
I have a question.
Yes, please.
About something that was a little bit earlier.
Yes.
You have the model with the explore, extract, explore, and all the three different
3x.
It takes me a little time to process this.
Yes, of course. There's a lot. There's a lot.
If you have a project that's more like a campaign, that you say, well, we have a marketing campaign, we need to build some software, it's only going to exist for 10 weeks.
Mm.
And then we're going to die it off. So you're never getting into extract.
Mm.
Where does it fit? Does it even fit?
So that campaign is.
Yeah, you might get 100,000 users.
So your product might be an extract, but it's just a campaign to get a bit of marketing.
No, you have to build something for a mobile app, for example.
Yeah.
It's for a certain campaign of a customer, and the app is only going to exist for 10 weeks.
Yes,
10
yes,
weeks or something like that.
yes,
Die off.
yes.
Is that something that fits in the model?
So it doesn't feel like it fits naturally here, because you might have a campaign like that year or year. I would rather say back to the end where we were. I would rather say, if you look at this, maintainability is a very low requirement, and often software engineers put that at the top, and for a good reason, because you can move from maintainability to scalability. You can move from maintainability to anything, but you can't move the other way around. So engineers prefer to put that at the top, but that's just not a high priority. So I would say it's more related to this model and the risks. There's very low risk in that thing not being maintainable. Something that's going to live for 10 years or 20 years, your risk of it might bring your business to a standstill if it's not maintainable. And that's the point of this talk, is that context is different, and these priorities will shift. Maybe in your case of your campaign, user experience is at the very top, because maybe they're only going to look at it for 10 seconds, and if it doesn't strike them and lead them to the right action and cause the right emotions, it's lost. So maybe that's way up there. Maybe reliability, I don't know if it's an email campaign, but hey, if a few emails don't go out, maybe it's not the end of the world. It's a very specific context. But I think it's hard for us as software engineers to switch. Some people say, some engineers are pioneers and some are town planners. You can't be both. Some personalities fit them, and I believe that, but I also think you can wear different hats. I think most software engineers are smart. They have the ability to adapt their approach.
The definition of engineer is that he can tries to accomplish the maximum amount within a limited set of options and rules. And if this helps to set your options and rules correct, optimize the problem correctly.
Yes, I like that constraint. Someone in a previous version of this talk actually said the constraints is maybe a better way to phrase it than risk. Just in line with what you mentioned. But yes, you always have constraints. Your other constraints are budget, time, cost of delay, real deadlines. Like a real deadline is, my one colleague worked on an election system. You don't want to really miss the election date. It can cause revolt and throw over the... Yeah, I should wait another 4 years. But then most deadlines aren't real. Most of the time, that's an artificial attribute. But I think getting these things visible is an agreement with product owners is important. I think one of the reasons why we've struggled so much as an industry is these priorities weren't understood by decision makers. It was IT as a cost center or development as a cost center mindset, and I think we're starting to move past that.
Do you have experience, like specifically setting these constraints within the team, and do you have experience how the engineers react to it or work with it?
I've done it in a few workshops, and just having the conversation with the product owner there already started changing the mindsets, and already started deprioritizing. So it had actually immediate effect that I didn't even expect a few times. Unless everyone already has a good idea, but when you suspect we're going about it wrong, then it might really have a good impact to try something like this. Yeah, so that's quality of service. I mean, none of this is new. These are old ideas. Then, okay, so those are the three factors. I just want to, my last idea is, it's dangerous. The idea behind this talk is dangerous, to say there's nothing like best practice and it's all just relative to your context. That opens the door to anyone saying anything, anytime, and doing it in any way. But I do think in a certain context there's a proper way to do things. And I also think there are a few things that always apply in software. And there are certain misconceptions that just still hang around. The first one is, I don't think it matters where you are, software needs to run. Continuous delivery, those kinds of principles, working software, for me that's a given in all the phases. The reason is good software needs feedback. Maybe in an extract phase, the feedback might be more about your quality, like regression tests. In an explore phase, the feedback might be user feedback. We hate this, we love this. But good software flourishes on feedback. It doesn't matter if it's enterprise product or a explore product. It requires good communication. People need to talk. I don't know of any other way to write good software. You can communicate via documentation. There's nothing wrong with that. You can have a lot of information in documentation, but the feedback is slow. There's a long latency with documentation. So that's why verbal communication is often better, because the latency and the feedback is higher. And then ultimately, it's software is a design activity. It's not a manufacturing activity. I think this is the biggest misconception that we've had to outgrow as an industry. I think the only part that works like manufacturing is the last part of that can be automated. Your continuous deliveries, automated tests, the DevOps side of things. That's the only side I think that's analogous with manufacturing. The rest is a design activity, and then it doesn't matter which phase you are in. That's my belief anyway. So just to wrap it up, and I think we'll have some time for questions or discussion, is these three factors helps me to think about the practices in the specific for the specific product, and we should throw away the concept of best practice and introduce the concept of context-specific good practice. That's pretty much the idea. I hope you go and have a look at some of these models. Yes, that concludes the talk. I don't know if you had any other questions. I don't know if we touched the topics of your own project.
Yeah, I'm still processing.
You're still processing.
It helps. I think.
I know it's a bit conceptual, and it's not a hands-on practical talk.
No, but for me the big idea is to set the constraints and openly talk about it within your team, and so everyone can agree about what level of maintainability do we need to get at this level, or how far are we going to push on quality. If we can talk about it and set the targets aligned, I think it will help a lot.
I like that conclusion of yours. It's about getting on the same page on what are we trying to do as a business, and what need are we trying to fulfill, and then what kind of quality are we trying to accomplish here. I think if you're not on the same page there, then
you get a lot of discussions about tools.
then you get a lot of discussion about tools, and at the end of the day, your customer suffers and your business suffers. Any other thoughts?
Well, actually, with the work I'm doing at the moment, we have like actually a ticketing system which we custom built. And now the discussion came up.
Sorry, I didn't mean to attack you.
No, it was funny to see that come up, and I look at it and I was like, hey, looks like we're trying to build Outlook here as well. So
Outlook as well.
yeah. So, but what would you say? How do you recover from such a situation when you finally figure it out? Because you might be way down the line, you're in a lot of code.
Okay, so your question is, what if you realize this after?
That you've done the wrong thing. You custom built something where you should have done a product or something else. Yeah.
Well, I mean, I would say the first thing is the focus should just be somewhere else. So to polish this and to keep on investing a lot into this part that's maybe not a big key part of your solution, I would maybe just spend less time on it for one, and then at some stage maybe evaluate your options. There's no answer here. You can only this model only leads you to the realization that there's a problem. That's all it can do.
I said, yeah, well, actually, it was also not very reliable component. So I said, yeah, well, let's just do the bug fixes and evaluate it at the meantime, which way we're going. So
Yeah, I think that's perfect. I mean, even replacing it might be an effort. So
yeah,
don't.
still it's going to be painful because we put it on, the team put a lot of time in.
Yeah, but you've heard of the sunken cost fallacy, right?
No, I haven't.
Well, I think we all have that. It's when you spend a lot of money on it, you think you're closer to success. But that's a fallacy. You want to believe it. Because you've spent a lot of money on something, you want to believe you're close to success. But it's an illusion.
Well, some people wanted to stop straight away with it, but I thought it was a bad idea as well because you don't have the owner system in place yet. So and you don't actually done a lot of bug fixing and customization of the ticketing system, which might not be in the new product. So
Yeah.
you need to have a bit of a conversation with the business as well.
So it's back to your point. It's just growing, getting everyone aware of where we are and where the real value sits and where the risk sits.
The key is finding the real value. If the value is in that ticketing system because you can, for some reason, deliver extra value to your customer because you do something unique, then it might be worth the investment.
Yeah, it's a pretty cool part of the system actually.
Oh, is the yeah. Yeah, and there's risk now. There's risk maybe in pulling it out.
There's risk in pulling it out as well. Because
Yeah.
otherwise the whole process might stop.
Right.
If I talk to customer, base my advice, custom development is expensive. So if you invest in custom development, always invest in something that makes the user experience or your product unique. Don't invest in something to be just as good as others. Because you can use default software and products. If you want to be better than the rest, then you need custom. And if this is the component where you can be better than the rest, then I think it might be strategically the right investment. If the highest achievable is to be at the same level as the rest, then kill it off. Kill it off.
Yeah.
You can't keep on innovating.
Yeah. And what I'm getting from this discussion is these tools are just to create that awareness of that context, because you're the only one that knows, has the situational awareness, can make the call. Yeah. Yeah, I find it useful. It's not that common in this software development community yet, but yeah, I thought it was useful. Yeah, thanks. Yeah, cheers. And thanks for staying the whole day, all four.